Okay, so section 12.4, volumes of prisms and cylinders. And let's go to the next slide. Here's a volume. These are your definitions at the beginning of this section here. The number of cubic units contained in its interior is the volume of a solid. And for this unit, it's just prisms and cylinders we're going to talk about for this 12.4. Volume of a cube. Postulate says that the volume of a cube is the cube of the length of one side. So the volume of this is going to be S cubed, one side. And we cube it, side times side times side. Volume of congruence postulate. That says that if I have two polyhedra that are congruent, so same, then they have the same area. Okay. The volume addition postulate says the volume of a solid is the sum of the volumes of all its non-overlapping parts. So just like we did when we had polygons so just like when we had composite figures, we could break them up into manageable pieces that we could find the area of. Well, we're going to do the same thing with volume. If we break it up into parts that don't overlap. So if you look at the 3D puzzle here on example 1, if we want to find the volume of this, we can break it up into chunks that we can find the volume of. And so if I do, let's kind of draw a line right straight across here. And I guess I should go back that way. So let's look at this base. And the area of the base is 7 times 2. 7 units long, 2 back, and then 1 high. So 7 times 2 times 1 is going to be 14. So the volume of that base, 7 back 2 and up 1. 7 times 2 times 1. Let's look at the upper left box. The left side. And so on the left side, we've got the width is 2. Let's do another color. The width is 2. The length is 2. And then the height is 1. So we get 2 times 2 times 1. And that's going to equal 4. And we'll pick another color, and then we'll do the right side. And the right side, 1, back 2 units, and up 1. So 1 times 2 times 1. And that's going to be 2. And so the volume of this, if I add up all of the pieces, is going to be 20 units cubed. Volume is a cubed unit. We were doing area, which was squared. Now we're in volume, which is a cubed unit. Okay, so here's our formulas. The volume of a prism is going to be the area of the base. So volume equals capital B. And you've learned from the last section that capital B means the area of the base times the height. So let's write that over here. B means area of base. So it's the area of the base and then times the height. And it's the area of one base. If you look at this, we're looking at this base right here. Now, is your figure always going to be sitting on the base? Not necessarily. Remember that your bases are the parallel sides. Now, in a prism, we can look at any of the parallel sides, opposite parallel sides, as being bases. But just make sure you pick 2. Here, on a cylinder, we have parallel sides being the circle on the bottom and then the circle on the top. Those are the parallel sides, so those are the bases. In volume, we only need one base, the area of one base, and then multiply by the height. So let's look at the volume of a cylinder, which is, again, base times height, volume of a cylinder, where we have to take a closer look, though, at what the base is. So what is the base? Well, I have a circle, and since my base is a circle, the area of the base is pi r squared times h. So for the volume of a cylinder, that would be your formula. Okay, let's find the volume of this solid. It's a right trapezoidal prism, which means my bases are trapezoids. And so to find the area of this base, remember that I'll write it up here, volume is base times height. Well, the area of this base, my base is a trapezoid. And so first let's find the area of this base. My base is going to be, and if you remember the trapezoid formula, I'm going to add the bases of the trapezoid. And so we've got to look at just the trapezoid now. Here's my trapezoid. And I think I can draw better on the one on the top than the one on the bottom. So the trapezoid here, I'll go to blue. This piece right here of that base is 6. That's what it tells me down here, 6 centimeters. And then base 2 is 14. So I've got 6 plus 14. Those are base 1 plus base 2 times the height of the trapezoid. And the height of the trapezoid is given to me right here. Remember, we want the perpendicular height between the two bases. And so that's my height right there that they're giving me, 3. Okay, add the two bases, multiply by height, and divide by 2. So the area of this base is 30. 30. Okay, and so area, remember, is a squared unit. That's centimeters squared. And now to get volume, that's what we're looking for, is the area of the base, which is our 30, times the height of the figure, the height of the solid itself. And that is the height between, the height is that height, that length between your two parallel bases. So between my bases right here, my height is 5 centimeters. So 30 times 5 equals 150 centimeters. And now we're cubed. We had centimeters squared for the base, and then I multiplied by 5 centimeters right here. That's 5 centimeters. So centimeters squared times another centimeters gives me the centimeters cubed. Okay, so that is the area of the right trapezoidal prism. Now let's look at the cylinder. If I want the volume of the cylinder, remember volume for a cylinder, base times height. However, my base is a circle, so this is going to be pi r squared times the height. So let's look at this. We've got the volume equals pi, my radius squared, which is 9, times the height, which is 6. So my volume is going to be 9 squared, which is 81, times 6 is going to give me 486 pi. So most of the times we're going to want these in terms of pi. There's your terms of pi, which is exact. Now, if your directions did say you could give me an approximation or to round to the tenths or the hundredths, then you could put this in your calculator and you would get 1526.81 feet cubed. Make sure that you pay attention to directions and what it tells you either exact or round to. And if it doesn't specify, you're safer just leaving it in exact. All right, I'm not going to do number 1 just because we'd already done a problem like it. Number 2, we're going to find the volume of a square prism. So first, on number 2, I'll see if I can draw a square prism with this pen. I'm going to do my best. There's a square prism, kind of. You could just go with me there. Square prism. Okay, it has a base edge length of 5 feet. So my bases are the squares right here, and then there's one back here, parallel sides, and it says square prism. And so the squares are going to be my bases. And so they have a base edge length of 5, and then a height, which is that distance between the two bases, of 12. So if I want this volume, I need the area of the base for a square. That's going to be base times height, or length times width, 5 times 5. And then times the height is going to be 12. So when we multiply that out, we're going to get 300 feet cubed. Volume is a cubed unit. And we were in feet, so we've got feet cubed. All right, let's look at number 3. The volume of a right cylinder, so I've got a cylinder here, is 684 pi cubic inches. And here's my height, 18 inches. All right, so remember volume, and we're talking a cylinder. So since my base is a circle, that's going to be pi r squared times the height. So let's plug in what we know to the formula. We know the volume is 684 pi, and that equals pi. Do I have a radius? No, that's what I'm looking for right here. So I've got r squared times the height of 18 inches. All right, so we have to solve for r squared. There's what we're solving for, r squared. So the first thing I'm going to do is get rid of everything around the r squared. I have an 18 and I have pi, so let's divide those out. 18 pi on both sides. 18 pi. And so I get rid of the pi and the 18 over here, and I'll have r squared. The pi's will cancel here, and I'm going to get 684 divided by 18, which is going to give me 38 for my r squared. Now, to get r by itself, you want to take the square root of both sides. And when I take the square root of both sides, that'll give me r equals the square root of 38. So that's an exact answer. You can plug it into the calculator if necessary, or if your directions say you can round to a certain point. And if you rounded, this would be, I mean, if you put it in your calculator, let's round to the 10th, 6.16, so 6.2. And this is in inches. Okay, so my radius would be 6.2 inches. Okay, on our next slide here, we have what's called Cavaliere's principle, which says if I have two solids that are the same height and the same cross-sectional area at every level, then they have the same volume. And really what that's saying is that if I have a figure like this that's oblique, an oblique cylinder, it's not right. It's not standing straight up tall, so that a height between the center points of the top and the bottom would be perpendicular at the bases. Well, we don't have that here. So we have to make the bases, we find that perpendicular height between the bases by coming outside of the figure. And this just says that I can use the same volume formula. So the same volume formula for this oblique cylinder would be pi r squared, the base, area of the base times the height. Still can use the exact same thing, and that's what this principle tells me. So pi r squared, my radius is 4, and then times the height, which is 7. So volume is 112 pi, and this is centimeters, so centimeters squared. And if you rounded, if you put this into your calculator and got a decimal, 351.86 centimeters cubed. And I made that mistake right here. That should be centimeters cubed. Sorry, we're on volume now. So that's centimeters cubed. Okay, let's do one more. Volume of this oblique for number 4. Volume, area of the base times the height. Here my base is a triangle. And so remember that for a triangle, the area of the base is 1/2 base times height. Well, it's a right triangle. It tells me that right here. It's a right triangle, so one of those measures is a base, one is the height of that base, which is a triangle. So I'm going to get 1/2 the base times the height of the base. Now when I talk about the base of the base, what you're looking for here is the area of the base. My two parallel sides are triangles. And then I'm going to multiply that by the height. So volume is going to be 180 meters cubed. Okay, now let's go over here and do number 5. This is one I really want to make sure you understand. What we're doing is we're taking the volume of the solid that's shown below. So this outside solid, the bases of that solid are triangles. I'll put a little dot here in the corner of the front triangle, and then if you look kind of at the back, they're triangles. Those are your parallel sides, so those are your bases. My base is a triangle. And then within that triangle, we're taking out this square prism right here in the middle. So it's a chunk that's coming out of the volume of that solid. So we have to subtract it. So we're going to find the volume of the triangular prism, where I'm going to need the area of one base. So let's find the area of the base of one of those triangles. To do that, I have equal sides. The tick marks here tell you that all the sides of the triangle are going to be 10 feet. So since we have that equilateral triangle where all sides are 10, we can use the equilateral triangle formula. And I'm going to write it up here in the corner. If you remember, it's s squared, a side squared, times the square root of 3 divided by 4. And so that area formula works for any equilateral triangle. So let's do that. One side is 10 squared times the square root of 3 divided by 4. So that's 100 square roots of 3 divided by 4, or 25 square roots of 3. So that's the area of the base. One base, that triangular base. Now, we're going to take that triangular base to find the volume of the prism, the triangular prism, and I'll just go TP to make sure you know this is the volume of the triangular prism. And the volume of the triangular prism is the base, 25 square roots of 3, times the height. And remember that your height is that distance between the two bases, between your two parallel bases. That is your height. So when I do 25 square roots of 3 times 6, this will give me 150 pi. Okay. So that's the volume of the triangular prism. Now let's find the volume of the square prism. We'll do this in red, square prism. And the volume of the square prism is the base, which are squares, 3 feet each, so base times height of the base, and then times the height between the two bases, 6. So we get 3 times 3 times 6, which is 54. And so if I wanted an exact volume, I would subtract these two, 150 pi minus 54, and that would be an exact value, feet squared, or feet cubed, sorry, I'm going to keep doing that for this unit, I think, feet cubed. But let's go ahead and do an approximation. Okay, have to go back and correct something. I don't know why I was getting to pi right up here. So this was 25 square roots of 3 times 6, which is 150 square roots of 3. I don't know where pi came from in my brain. So down here, again, 150, not pi, but the square root of 3. You guys are all probably sitting there going, what is she talking about? So 150 square roots of 3 is about 259.8. And then if you subtract the 54, I'm going to get about 205, so this is approximately 205.8. And this was in feet. I'll write it up here since I'm out of room. Cubed. Okay, there you go, 12.4.